So in this video, we're going to talk about circles and triangles. Some of it may seem kind of elementary to you, but you might need a refresher on how to find some certain properties of circles and specifically right triangles, what we're going to focus on. So some vocabulary that I'm going to use that I need you to understand what I'm saying are these words here. Radius, that's the distance from the center of a circle to the edge of a circle. Diameter, it's twice as long as a radius. It goes across the circle and it passes through the center. So that's why a diameter is twice the distance of a radius. Circumference, that's the distance around the edge of a circle. So it goes all the way around the edge. That's what makes the circle, arc length, that's just a fraction of the circumference. So arc length is just a small part of the edge of a circle. So those are some basic terms there. When I say all of those words, I hope that you know what I'm talking about. Some other words that might be a little bit less common is something called a sector. If you think about pizza or pie, anything like that, you know that you can cut up a circle into pieces, and each of those pieces fits together into the circle. These pieces are usually called sectors. And then the angle that that sector makes with the radii that cut that piece out, that's something called the central angle. So this one over here, that's our central angle for this particular sector that I have. Now, all of the central angles added together of all of the sectors of a circle have to add up to 360 degrees. So in this particular example right here, this central angle plus this central angle for that other sector, the remaining section of the circle, those two sectors, central angles have to add up to 360 degrees. To calculate a couple of important quantities here, to calculate that circumference or the distance around the edge of the circle, you can use that the circumference is 2 pi times the radius. Or if you remember, a diameter is twice the radius, so you can also use that circumference as pi times d, the diameter of the circle. Pi is just a constant, it's the number 3.14, and then a bunch of other decimal points. So I'm sure that you guys know that. Area, to calculate the area, is the space covered up by this circle. You could use these two equations. The one you probably know is the area is pi r squared. And again, if you remember that the diameter is twice the radius, then you could substitute that in there and you would get an equivalent equation that says that the area is pi times d squared, and all of that divided by the number 4. So that's how you can calculate circumference and area of a circle. Notice that circumference is a length, so it will have units of distance like meters or feet, centimeters. Area is a space. It's like a two-dimensional amount of space. And so area will have units of distance squared. Notice in those equations, the radius is being squared. So the radius has units of length, and then you're squaring that. So for area, you'll get units of meters squared or feet squared. Just be aware of that and make sure that you're getting the correct units if you're calculating circumference versus area. Now let's move on to triangles, and specifically really we're just going to talk about right triangles. There's some specific vocabulary again that I need you to understand. When I say these words, I need you to be on the same page as me. The first word is adjacent. That word means next to. Opposite in this mathematical context means across, from. So for a right triangle, there's one angle in the triangle that has a 90 degree angle. And the side of the triangle that is opposite of that right angle is called the hypotenuse. So in this picture that I have right here, our right angle is down here. So something that is across from that angle, that's the hypotenuse. Remember that the hypotenuse is opposite or across from the right angle. A leg is just the other two remaining sides of the triangle. So the hypotenuse is special. That one is across from the right angle. It is the longest side of the right triangle. The other two sides, those are called legs. To calculate some things within a right triangle, you might use something called Pythagorean theorem. This theorem says that the length of the hypotenuse squared is equal to the sum of the sides of the legs squared. So to kind of write that down, you might have heard like a squared plus b squared is c squared, just to kind of write it in the same words that I used in the sentence above. I would write c squared is equal to a squared plus b squared. It's the hypotenuse, the length of that hypotenuse squared is equal to the sum of each of the sides squared. So make sure that you label your sides correctly, that c is always the hypotenuse, which is opposite from that right angle. And then the two legs are just labeled A and B. It doesn't matter which is which when you're doing Pythagorean theorem. To calculate area, another equation you might use for triangles. This is true for any triangle. Area is 1/2 the base times the height. For right triangles, it's actually a little bit easier to calculate area because one of your legs is going to be the base and one of your legs is going to be the height. The definition of base and height are the two legs of a triangle, or two measurements within a triangle that are perpendicular to each other. So for a right triangle, it's automatically the legs of a triangle. If you're talking about different types of triangles, the side lengths might not be equivalent to the height of that triangle, but don't worry, we're going to focus on right triangles here. So 1/2 base times height. Again, notice that when you're calculating area, you have a base, which has units of distance, times a height, which has units of distance. So the units of area should be some kind of distance squared. So feet squared, meters squared, centimeters squared. All of those are appropriate units for area. Now let's get into some slightly tougher equations that you might not have as much practice with. These are called the basic trig functions: sine, cosine, and tangent. They are special functions that need an argument. They need some kind of input that you put into that function. The function does some calculations and the function spits out a new number for you. So the thing that you put into the function, for these ones we call that the argument. You can think of it as the input. It's some number that you're putting into the function. Then the function does its calculation and it gives you back another number. That's the output of the function. So in order to use these functions, sine, cosine, and tangent, you need to label your right triangle according to these three names. The hypotenuse is still the hypotenuse. It's the it's the side of the triangle that is across or opposite from the right angle. It's the longest one in the right triangle. Then you have the two legs of the triangle. You're going to label one of them opposite and you're going to label one of them adjacent. The question is, what are they adjacent to? What are they opposite to? And it all depends on the angle in the triangle that you know. So if you say, let's say that we know this angle over here that's labeled theta. Notice that this side is adjacent to theta. This side over here is opposite. It is across from theta. So adjacent means next to, opposite means across. So depending on which angle you're talking about in this triangle, you might label the legs or the sides of the triangle differently. So for this particular picture, where I was given this angle theta, that's why I would label this triangle. A is the one right next to it, and O is the one across from it. Once you've labeled your triangle like this, then you want to use these functions that they're already been defined, and you need to just know their definitions. So sine, cosine, and tangent, you may have seen this mnemonic device called SOH-CAH TOA. It kind of helps you remember the relationships between sine, cosine, tangent, and then the various sides of these right triangles. So the sine of theta, theta is the thing you're putting into the function. The sine of theta is equal to the length of the opposite side divided by the length of the hypotenuse. Cosine, the cosine of theta. Theta is the thing going into the function. Then the function spits out the length of the adjacent side divided by the length of the hypotenuse. Then you have tangent. Tangent of theta, that's what you're putting into that function as theta goes in, and out comes opposite length divided by adjacent length. There are also what we call inverse trig functions. If you need to undo a certain operation, you do the inverse operation. So like multiplication undoes division, division undoes multiplication, subtraction undoes addition. So those are inverse operations. So there are also inverse trig functions. So whenever you need to get an angle, when you need to get that argument out of the trig function, you need to do an inverse trig function. So if you start off with our basic definitions here that we just learned, and you do the inverse on both sides. Whatever you do on one side of an equation, you have to do on the other side of the equation to keep everything equal. So notice that you have the inverse sine function, and the argument of that is sine of theta. If you're doing the inverse of sine and you input sine into that function, those two things undo each other. And so what you get is you get the theta gets plucked out of that function. So theta is equal to the inverse sine of the opposite side divided by the hypotenuse. So that mnemonic device, SOHCAHTOA, still makes sense with these inverse trig functions. That inverse sine still is related to the opposite and the hypotenuse. Inverse cosine is still related to the adjacent and the hypotenuse. Inverse tangent is still related to the opposite divided by the adjacent. Notice that the thing you're putting into these functions is that ratio of the two sides, and the thing you're getting out, the output, is now an angle. So let's do just a few quick examples here to kind of give you a little bit of practice using these functions. Let's say I've given you this triangle here. It has a hypotenuse of 10 centimeters, and I've labeled one angle 53 degrees. We're going to try to figure out the lengths of the legs of the other two sides of the triangle using trig functions. So the first thing I'm going to do is redraw the triangle, and I want to label the sides. So the side across from the across from the right angle, that's the hypotenuse. I'm going to call that H. The angle that I gave us, that one labeled theta right there. Well, opposite from that angle, I'm going to label that side O. It's opposite from this angle that's labeled theta. Adjacent to that side, I'm going to label A. So make sure you've labeled your sides correctly. Then I'm just going to write down my trig functions. I know that the sine of some angle is equal to the opposite over the hypotenuse. So because I don't know the opposite side, I need to algebraically solve for it. I'm just going to multiply both sides by h. And so I get that the opposite side is equal to the hypotenuse times the sine of theta. So now I plug in all my known things. The hypotenuse was 10 centimeters, the sine of 53 degrees. Plug all that stuff into your calculator, and you should get something very, very, very close to 8 centimeters. If you round it, you can go to 7.99 if you want. If you wrote down 8, that's fine. Now to get that adjacent side, I'm going to use the cosine function. So the cosine of theta is the adjacent over the hypotenuse. Again, solve for the side you're looking for. So multiply both sides by h. That'll get a all by itself. Then I want to plug in all my numbers. And I'll finally calculate there that A is about 6, somewhere very, very close to 6 centimeters. And so now I just want to go back and relabel my triangle and give you my final answer here. That's the lengths of all of those sides of my triangle using the trig functions. You could have also incorporated Pythagorean theorem into this if you wanted to. Once you knew one of those legs, you could have used Pythagorean theorem to get the final leg of that triangle. All right, one more example here. Now let's get a little practice using the inverse trig functions. Let's say that we have two vectors. Here's vector D, and I know some information about the dimensions of vector D, that it's pointing up with a length of 6 meters and it's pointing to the left with a length of 15.5 meters. Vector B is a vector that points perfectly to the right. I don't know how long it is exactly. The question is, determine the angle, the smallest angle named psi that this vector D makes with vector B when they're placed tail to tail. First thing I'm going to do is I'm going to redraw them so that they are tail to tail. And I'm going to label this angle that I'm looking for. So this is the angle psi. That is the smallest angle between vector D and vector B when they're drawn tail to tail. The next thing I'm going to do is kind of split that angle up so that I can figure out the full total angle by finding it in pieces. So if you kind of draw a vertical line there, that the angle that B makes with that vertical line is a 90-degree angle. because those two things are perpendicular to each other. And I'm going to call this other angle, I'm going to call that one theta. I need to figure out what that angle is, but I can use that triangle that vector D made about those dimensions. I can use that to get theta. And I'll just use this relationship here, that 90-degree angle plus theta, those two things added together will give me psi. So let's redraw this triangle. We'll redraw the vector as a triangle, where the hypotenuse is the norm, or the length of vector D. And then the two legs of that triangle are the two sides that were given to us in the picture. And we need to figure out angle theta. So we do not know the hypotenuse right now, but we do know the side that is opposite from theta. So that's opposite. And we do know the side that is adjacent to theta. So let's use an inverse trig function to get that angle. Well, I know that the tangent of theta is the opposite over the adjacent. I take the inverse tangent of both sides. That plucks theta out, it undoes the tangent. And so I get that the theta is equal to the inverse tangent of opposite over adjacent. I just plug in those numbers. Notice that the meters and the meters are going to cancel each other. You have a ratio of two side lengths, and you need to have those two units equal to each other. You can't mix your units. But once you have those two units that are the same, then they will cancel out. So based on all that, I get my measurement there for theta. And make sure your calculator is in degree mode. And then when you do inverse trig functions, the answer will be in units of degrees. And so I got 68.8 degrees. Now I just go back up to my definition up here for psi. And so psi is going to be 90 degrees plus that 68.8 degrees. So my final answer is 158.8 degrees. All right, so there's a couple of examples. Definitely you probably need some practice on your trig functions. But these are the only ones we're going to use. That's the extent of trig that we're going to use in this course.